Buckle up, science fans! The world of aviation is on the verge of a thrilling transformation. We're talking about a revolution in the skies, driven by a new breed of aircraft. These aren't your typical planes, they are technological marvels, engineered to redefine the very principles of flight. Imagine this: aircraft that pierce the sound barrier, whisking you across continents at mind-boggling speeds. Picture planes soaring on biofuels, leaving a minimal carbon footprint. Envision a future where air travel is not only faster and more efficient, but also sustainable and accessible to all. This isn't science fiction, folks. This is the future of aviation, and it's closer than you might think. The driving force behind this revolution is a potent combination of cutting-edge technology and innovative design. We're talking lightweight materials, advanced aerodynamics, and revolutionary propulsion systems. These advancements are not just incremental improvements, they represent a paradigm shift in how we approach air travel. This new generation of aircraft is challenging the status quo, pushing the boundaries of what we thought was possible. From supersonic flight to eco-friendly operations, these planes are poised to transform the aviation industry as we know it. Get ready, because things are about to get really interesting. So what makes these aircraft so special? Let's dive into the heart of these engineering marvels and explore the technological innovations that set them apart. One of the key breakthroughs lies in the use of advanced materials. We're talking lightweight composites, like carbon fiber reinforced polymers, that are stronger and lighter than traditional aluminum alloys. These materials not only reduce the overall weight of the aircraft, leading to significant fuel savings, but also enhance its structural integrity. This means these planes can withstand greater stress and strain, making them ideal for high-speed and high-altitude flights. Remember those sleek, futuristic designs we talked about? They're not just for show. These aircraft feature advanced aerodynamic designs optimized to reduce drag and improve fuel efficiency. We're talking about blended wing bodies where the wings seamlessly merge with the fuselage, and innovative engine placements that minimize drag and noise. But the real game changer lies in the propulsion systems. Forget about your grandpa's jet engines. These aircraft are powered by next-generation engines that are more fuel-efficient, quieter, and produce fewer emissions. Think hybrid electric engines, biofuel-powered turbines, and even the possibility of electric propulsion for shorter routes. The implications of these technological advancements extend far beyond faster flights and fuel savings. These aircraft have the potential to revolutionize air travel as we know it, impacting everything from airline operations to the passenger experience. Imagine boarding a plane that whisks you across the Atlantic in half the time it currently takes. Think about the possibilities for business travel, international commerce, and even family vacations. These aircraft could bring the world closer together, making global travel faster, more efficient, and more accessible. But the impact goes beyond just speed and convenience. The increased fuel efficiency of these aircraft translates into lower operating costs for airlines, which could lead to more competitive airfares for passengers. Imagine a future where flying is not only faster and more convenient, but also more affordable. And let's not forget about the environmental benefits. The use of biofuels and hybrid electric propulsion systems has the potential to significantly reduce the carbon footprint of aviation. This means cleaner air, less pollution, and a more sustainable future for air travel. Let's take a closer look at how these aircraft are redefining efficiency, starting with the all-important aspect of fuel consumption. Traditional aircraft are notorious for their thirst for fuel, but these new-age planes are changing the game. The use of lightweight materials combined with advanced aerodynamics significantly reduces drag, allowing the aircraft to cut through the air with minimal resistance. This translates into less fuel burned per mile, leading to substantial fuel savings and lower operating costs. But it's not just about reducing fuel consumption, it's also about exploring alternative fuel sources. These aircraft are designed to run on a mix of traditional jet fuel and biofuels, derived from sustainable sources like algae or plant oils. Biofuels have the potential to significantly reduce the carbon footprint of aviation, as they release fewer greenhouse gases when burned. This shift towards sustainable aviation fuels is crucial in mitigating the environmental impact of air travel. Moreover, some of these aircraft are even exploring hybrid electric propulsion systems, combining the power of traditional jet engines with electric motors. This hybrid approach further enhances fuel efficiency, especially during takeoff and landing, when fuel consumption is typically highest. Section 5. The sonic boom dilemma. Navigating noise. One of the challenges with supersonic flight is the sonic boom, that loud, disruptive noise that occurs when an object travels faster than the speed of sound. It's a major concern, especially when flying over populated areas. But fear not, science enthusiasts. Engineers are hard at work developing innovative solutions to mitigate the sonic boom. One promising approach involves redesigning the shape of the aircraft to minimize the shock waves that create the boom. These new designs, often featuring long, slender fuselages and carefully sculpted wings, aim to distribute the shock waves more evenly, reducing their intensity and making the sonic boom less noticeable on the ground. Another strategy involves using advanced engine technologies to control the airflow around the aircraft, further minimizing the formation of shock waves. Think of it as manipulating the sound waves to soften the boom. While these technologies are still under development, they hold great promise in making supersonic flight more acceptable for both passengers and communities on the ground. Quiet supersonic flight? Now that's something to get excited about. Section 6. Greener skies. Emissions and sustainability. The quest for faster and more efficient flights shouldn't come at the cost of our planet. That's why sustainability is at the forefront of this aviation revolution. These aircraft are designed not only to be fuel efficient, but also to minimize their environmental impact in every way possible. The use of biofuels, as we discussed earlier, is a major step towards reducing greenhouse gas emissions, but it goes beyond just the fuel. These aircraft incorporate recycled and recyclable materials in their construction, minimizing waste and promoting sustainability from the ground up. Furthermore, the advanced engine technologies, with their improved combustion efficiency and reduced emissions, contribute to cleaner air and a healthier environment. These engines are designed to meet stringent emission standards, minimizing their impact on air quality. The aviation industry is also exploring innovative ways to make ground operations more sustainable, from electric-powered ground support equipment to optimized taxiing procedures that reduce fuel burn and emissions. It's a holistic approach to sustainability, ensuring that every aspect of aviation, from design and manufacturing to operation and maintenance, is as environmentally friendly as possible. Section 7. A paradigm shift in design philosophy. The revolutionary nature of these aircraft extends beyond just the technology. It represents a fundamental shift in design philosophy. Traditional aircraft design often focuses on incremental improvements, building upon existing concepts. These new-age planes, however, are breaking free from those constraints, embracing radical ideas and pushing the boundaries of what's possible. It's about challenging conventional wisdom and exploring entirely new approaches to aircraft design. Take, for instance, the concept of blended wing bodies. Instead of the traditional distinct fuselage and wing structure, these aircraft seamlessly blend the two, creating a more aerodynamically efficient shape that resembles a giant flying wing. This radical design not only reduces drag and improves fuel efficiency, but also opens up new possibilities for cabin design, potentially offering passengers more spacious and comfortable seating arrangements. Another example is the exploration of distributed propulsion systems, where multiple smaller engines are distributed along the wingspan instead of the traditional two large engines mounted under the wings. This distributed approach offers several advantages, including improved fuel efficiency, reduced noise, and even enhanced safety in case of engine failure. Hold on tight, because we're about to take a peek into the cockpit of the future. These revolutionary aircraft are not only changing the way planes look and fly, but also how they're piloted. Automation and artificial intelligence, or AI, are taking center stage, transforming the role of pilots and enhancing flight safety. Imagine a cockpit with fewer dials and gauges, replaced by sleek, intuitive displays that provide pilots with real-time information about the aircraft's systems, flight path, and surrounding environment. That's the power of automation and AI at work. Advanced flight control systems, powered by sophisticated algorithms, can handle many of the tasks traditionally performed by pilots, such as maintaining altitude, speed, and navigation. This allows pilots to focus on more strategic decision-making and monitoring the overall flight. AI-powered systems can also analyze vast amounts of data from various sensors and sources, providing pilots with enhanced situational awareness and helping them anticipate potential issues before they arise. It's like having a co-pilot with superhuman analytical capabilities. But don't worry, pilots aren't going anywhere. While automation and AI are playing an increasingly important role, human pilots will always be essential for their experience, judgment, and ability to handle unexpected situations. Introducing such revolutionary aircraft into the skies isn't just about technological advancements. It also requires navigating a complex web of regulations and ensuring international cooperation. These aircraft are pushing the boundaries of existing aviation rules and standards, necessitating a reassessment of safety protocols and certification processes. For instance, supersonic flight over land is currently prohibited in many countries due to concerns about sonic booms. The development of quieter supersonic technologies will require updating these regulations to accommodate this new era of faster-than-sound travel. Similarly, the use of biofuels and alternative propulsion systems will require new standards and certification procedures to ensure their safety and reliability. International cooperation is crucial in harmonizing these regulations and standards to facilitate the global adoption of these new technologies. The aviation industry, regulatory bodies, and governments worldwide need to work together to establish clear guidelines, safety protocols, and certification processes that foster innovation while maintaining the highest levels of safety. It's about striking a balance between progress and prudence. The impact of these revolutionary aircraft extends far beyond the aviation industry itself, with the potential to transform the future of travel and connect people and cultures like never before. Imagine a world where supersonic flights make international travel faster and more convenient, shrinking the globe and bringing distant corners within easier reach. These advancements could revolutionize business travel, enabling companies to conduct business across continents with greater ease and efficiency. Imagine attending a morning meeting in London and being back in New York for dinner. But it's not just about speed and convenience. The increased fuel efficiency and reduced operating costs of these aircraft could make air travel more accessible to a wider range of people. Imagine a future where flying is no longer a luxury but a viable option for more travelers. Moreover, the focus on sustainability and reduced emissions aligns with the growing global emphasis on environmentally friendly travel. These aircraft offer a glimpse into a future where we can explore the world without compromising the health of our planet. As we've explored, a revolution is taking flight in the world of aviation. From supersonic speeds and biofuel-powered engines to advanced automation and a renewed focus on sustainability, these aircraft are poised to transform the way we travel, connect with the world, and perceive the possibilities of air travel. These advancements are not just about making planes faster or more efficient, they're about reimagining the entire flying experience, making it more sustainable, accessible, and awe-inspiring. It's about pushing the boundaries of human ingenuity and embracing a future where the sky is no longer the limit, but the beginning of limitless possibilities. So buckle up, science fans, and get ready to witness a new era of aviation unfold before your very eyes. The future of flight has never looked